See you there. Now, without further ado, give it up for Tim Ojo.
Is it on? All right. I always want to say that. Make this, it's all right. It's big enough. Oops. All right, my name's Tim Ojo. I'm a husband, father, Christian developer, Patriots fan, not in any particular order. I am not a DBA. I'm a developer with a focus on performant scalable systems. I have interest in data analytics and machine learning. That's what brings me to the database layer, because a lot of times when you have to scale, you can get a bottleneck at the database layer, and that's an interesting problem we try to solve at AudiencePoint. I work at AudiencePoint, by the way. I'm also not a polished public speaker, as you can tell. This is just my second time doing it. I didn't get any better since the last time, so get ready for another crappy one. But at least there's pizza this time. So last time there wasn't pizza, so that sucked. So here we go. Here's what I've got to offer in the way of introduction, if I can figure out where my slides are. All right. Man, I can't get anything right. Okay, what this talk is not. This talk is not a deep dive talk. We're not doing any deep dives. There's not enough time. There's lots of databases, lots of things to cover. I'm going to try to cover about 6 categories and 15 databases in 35 to 40 minutes. Keyword being try. If I don't cover it all, I'll just cut it short and see if there's any questions. Also, this is not a comprehensive look at all the databases out there. It's not a comprehensive survey. So if I leave out your favorite database, don't go grumpy cat on me. Just leave a comment in the comment section, with the trolls and fanboys. But in all seriousness, focusing basically on the sort of the popular or most widely used ones in each different category, because when you go to build an application and you put a database underneath it, you probably don't want to be using someone's pet project, and then they say, okay, I want to do something else, and you have an unmaintained database on your hand. You want them to stick around for the long haul, so I'm doing that as well. Lastly, there's a little bit of if this, then that, but it's not meant to be absolutely prescriptive. It's just advice from my expertise and my research. Your situation and mileage may vary. Things may have changed with some databases. I may be wrong about something. I'm not afraid to get called out on it, so go ahead and do it. Right? That way everyone learns. That's what we're doing here at ChawDev. Right? That's why we come to ChawDev. Well, that and free pizza. So again, introduction. In the end, every database is simply an extraction over file storage. This is not me. This is Alfred Mutilli. He is a podcast host of one of the podcasts I listen to. I found it to be pretty insightful. That in the end, with all these myriads of choices, 102 or so and counting, it all comes down to storing bits on a disk, right? But the keyword there is abstraction. We all build abstractions. As developers, we all build abstractions, and we build abstractions to solve a problem, right? The common saying is that the answer to every computer science problem is an extra layer of abstraction. And when we build abstractions to solve problems, we make design choices. When we make design choices, there's trade-offs involved. So if you're trying to apply a particular abstraction or a particular solution to particular problem that wasn't built for, those trade-offs could come back and bite you in the butt, or they could work for you. You could sometimes do workarounds, but isn't it better to just pick the right one for the right problem? And so here are some things that you should consider. You should consider the nature of the data. Are we talking about event streams? Are you doing activity streams, click streams, log streams, those kinds of things? Readings from an IoT device. Are we talking about record and list-oriented data? Lists of financial transactions, lists of students. Are we modeling objects in the real world? Is it a movie database or something like that? Are we talking about highly connected data? Is it temporal data like user sessions or a cart. Those kinds of things need to be thought of, need to be considered when you're trying to pick the right database for you, because different databases work well for different types of those data. Also, the nature of operations. Is it write once, read many? Which is many sort of like blogs or websites out there. Is it write intensive? Is it insert only? For the longest time, Facebook posts were insert only. Once you wrote a post and put it out there, you couldn't edit it. And that's because it's pretty expensive to do so at the scale at which they're running. What are your query requirements? Do you need ad hoc querying capabilities, or can your queries determined beforehand? Also, there's obviously the business needs of scalability, availability, flexibility, any kind of other entities, performance, consistency, and speed to market. And there's cost. How much does it cost? That's also a factor, right? If you're not building something, right, you don't have to go buy a big Oracle box if you don't need it. What are the hardware requirements? What are your hardware requirements? What are the support options? Again, like I said, long-term viability. Is it my coolnewdb.com on GitHub that's going to go away in a year? So let's go to the natural jumping point: SQL databases. When you need SQL databases are a great general-purpose database. They store a variety of, they address a variety of use cases, and they can store a variety of data types. The proof is that we've used them for 30 years or more, and we will continue to use them for many more years to come. It's like C or C++. It would never die. I wish it would, but it won't. Not databases C or C++. They do come with a little bit of complexity. You're expected to normalize your data, break it up into little pieces to avoid duplication. But once you can do that hard task, you do get quite a bit of flexibility in terms of queryability. You get arithmetic functions, aggregations, advanced features like views and stored procs and triggers. SQL was designed for humans. If you look at the SQL language, clearly you can see that there's not a lot of cryptic symbols and parentheses and squiggly braces and open brackets and things like that, right? It's simple, select this from that, order by this, or insert this into that. So the benefit is that a business analyst can go sit at a terminal and reasonably manipulate data and say, this is what I want, and get it back from them. Get it back. There's 3 sort of really popular commercial ones. Oracle, which is sort of the market leader. SQL Server, which I think is a great database. It cuts out most of the crap and just gives you a simple database. Also, it comes with a Microsoft license. So if you're in the Microsoft stack and the Microsoft shop, it's free. IBM, yeah, as free as free could be, right? DB2, if you're paying IBM a lot of money, it's free too. And then there's the open source databases. There's MySQL and Postgres. MySQL has been around for a long time. It's sort of the standard in open source databases, in that it runs a lot of big websites that you know about. But I guess you won't say new, but the hotness is Postgres. Postgres is pretty awesome according to everybody that I trust. I haven't actually used it. Postgres, most open source projects are switching to Postgres. Postgres can do, you can treat it as a document store if you want to, because it's got JSON-B bindings. You can treat it as a document store. No, it can also act as a proxy or a sort of a centralized place to connect to other databases using its foreign data wrappers. So you could connect to a Postgres instance and connect to Neo4j or Mongo on the back end or some other database. So right, if I did have to, so if you're making a choice and you just don't want to think, I'd say go with Postgres. But so you can leave now, most of you. But no, just kidding. There's more. When should you use a SQL database? So when you have record-oriented data, like I talked about. If you need full asset guarantees, you're doing complex things. You're in the checkout process, and you're right. A checkout process starts with charging the credit card and taking the item out of inventory and then adding the item to somebody's order, and all these things need to happen atomically. They need to happen once and pass or fail. You can't do that with any other database right now. Any other database other than the relational database. In some ways, you can do it with graph databases, but it's harder. If you need ad hoc querying capabilities, if you need granular security at the database level, or if you're just familiar with it and you don't want to mess with what the kids are doing these days. When should you not use a SQL database? Well, let's start with the two main drivers for NoSQL. Were horizontal scaling and ease of use, or operational simplicity. If you need to scale, you're not going to get too much of that on the relational database because relational databases offer vertical scaling. Sure, if you work them hard enough, you could try to scale them horizontally and shard them, but why? And also, if you need rapid deployment for fast time to market. You just want to forget that there's a database back there. You just want to start coding. Which, right? These two things, the top two are basically the descriptor for many web startups out there today, right? We think that we're building the next Facebook, and so we want to scale and we want fast time to market. We want to be able to change things on the fly. So that's why NoSQL is taking off. And of course, if your data doesn't fit the relational model, you should look into NoSQL databases. But before we get there, let's talk about embedded in-memory databases. Sometimes you just want something small. Sometimes you just it's instead of chucking the file into a database into a file system, you want to put a database out there. Embedded in-memory databases are, and I think there's a guy coming and give talk about that 2 weeks from now or so. They are basically libraries that you embed in your code, and you say, there's no configuration necessary. There's no management necessary. You basically just say, here, store this. Here, give this back to me, which is right the dream, right? You just have some data. Take care of this for me. Hold this for me. Give it back to me. There's lots of flavors here. Well, there's a couple flavors here. SQLite, Loki.js, CouchDB, OrgoDB. SQLite is probably used everywhere. You have it on your phone, on your Android phones, you just don't know it. On your iOS devices. A bunch of Apple's apps have it as their backing store. I mean, I'm talking about OS X apps. It's an integral part of Windows 10. It can run the SQLite website itself. I'm sorry about that. The SQLite website. The SQLite. All right, skip SQLite. Loki.js. Loki.js is JavaScript. Is a JavaScript library. It runs in the browser or Node.js or in Node. And it's you pass it. You hand it again. In memory embedded light. You hand it JS file, JSON objects, and it stores them, and you can query them back. Its interface is partially compatible with MongoDB, so if you used to working in MongoDB, you can work with Loki.js pretty easily. CouchDB is similar, it's exactly the same thing actually, except that its interface is 100% compatible with CouchDB or Couchbase. And not just that, but it also syncs to CouchDB or Couchbase. So if you're following the sort of like the offline first movement, or not, if you just want to perform all your operations locally, perform all your inserts, updates, deletes, or puts, gets, posts locally, and then have it just sync to CouchDB in the background or so. That works really well. Or you could have it sync to another CouchDB instance or another CouchDB instance. It's peer-to-peer, so you could have a really amazing network. When should you use them? If you need to fit into tight spaces. If you're building a desktop, mobile, embedded server, basically anything where, or low traffic website, 100,000 hits per day, which is good enough for a lot of websites. As a local cache, or if you want to do rapid development and prototyping, again, you don't want to worry about what's back there. Somebody, your DBA or your DevOps guy is provisioning a server for you, but while they're doing that, you want to get started. You're going to be using Mongo, or you're going to be using SQL, or you're going to be using Couch. You can get started with one of those. MongoDB is a .NET object in-memory database, so you can check that out as well. All right, key value stores. I'm going to try to breeze through key value stores because they're conceptually simple. It's a key value. I mean, who doesn't understand a key value store? If you don't, well, let's just leave it there. Right, you store, right, you've got a key, you've got a value, you hide it behind a key, you say, give me this value, give me this value back. They typically run in memory. Your big two are Redis and memcached, but they assume that you can hold your entire data set in memory. Memcache doesn't actually have it doesn't actually have persistence. So if you put data in memcache and you shut down your server, you say bye-bye to your data. But Redis does. Redis has two forms of persistence. You can either take snapshots of memory and then write it to disk, or you could do an append-only log kind of thing. Memcache has because Memcache is sort of simpler and was way before Redis. Redis builds on the lessons learned from Memcache. So Redis is almost always a superior choice. The only times when Memcache should be a superior choice is if you have, because Memcache stores its stuff as strings. So if you have small immutable strings, you put it in there, and it can use memory a little bit more efficiently than Redis, because Redis can do a lot more. So it's a little bit more of a memory hog there. When to use them? Use it as a caching layer. If you have temporal or expiring data, like a user session, that's gonna expire after an hour, or a shopping cart that's gonna expire after an hour, or a power up in a game. You've got a power up. It's gonna you've got a power up for an hour or so. You can use it for that. Redis has sets and lists and stuff, so it's used a lot as a queue for background jobs for many websites. Riak doesn't get as much love, and that's because Riak is built for high availability and big data in mind. Riak also has a little bit of identity. No Riak? All right, let's try it again. Riak also has a little bit of an identity crisis in that it's also used a lot as a document store. Not just a key value store, but Riak is, again, built for big data in mind. They recommend that you have at least 5 nodes in a cluster, and it is built on the Amazon Dynamo theory, or Dynamo stack, Dynamo paper, where it's got master-master replication, peer-to-peer. So it's really built with high availability in mind. And it's built for when all your data can't fit in memory. It actually does persistence pretty well, which is much better than you can say for Redis. When not to use it, if persistence is important to you. You want to look at the workhorse of the NoSQL world, which is document databases. Document databases are designed to be a SQL database replacement for the web, meaning that they're general purpose databases. The general purpose databases, all your data is encapsulated into one entity. So what you would model relational, like if you're modeling a user, and you had the user, and then you had address, and you had an address off in a separate table, because there could be multiple addresses. With document databases, you would just bundle that into one object and store it there. They're schemaless, and because you avoid joins by denormalizing and bundling your data into one document or so, it can scale really well, really easily by via sharding, consistent hashing sometimes on commodity hardware. So another thing about document databases is you can run complex queries with them. So that's why they're the general purpose database for the web. You can do aggregation like queries, pagination, server-side pagination, group bys, range queries, some things that you can't do on many other types of NoSQL databases. To allow that to happen, it allows table scans. Which most other databases are variations of a key value store, which don't allow table scans. Flavors out there: MongoDB and Couchbase or CouchDB, which Couchbase is basically CouchDB plus Membase. And then we've talked about Riak. MongoDB is sort of the gold standard out there. It has the hearts and minds of developers. But a couple of reasons to give the little guy, well, I don't think they're the little guy. A couple of reasons to give the little guy a shot, which would be Couchbase, is that in the CAP theorem, and I don't think I have time to explain the CAP theorem today, but the CAP theorem basically says that if you have a partition-tolerant database, meaning if you have a distributed database, you need to choose between high availability or high consistency. And MongoDB sits on the high consistency part of the CAP theorem because it's got master-slave replication. So there is a single point of failure. If the master goes down, there's a time in which there needs to be an election for a new master. Whereas CouchDB is master-master replication. So they're all masters. They all get the database. They all get the data eventually. So it's eventually consistent. So if you need truly high availability, you can never have a second of downtime. You want to look at Couch. If you need high consistency, you want to look at Mongo. Again, Couchbase also has memcache built in. So if you don't want to run, if you need a caching layer and a document storing, you don't want to run two, you can look at Couch Database, and also it's got a SQL-like query language, so it's comfortable for those coming from SQL. When to use them, of course, horizontal scaling and fast times to market, flexible schema. When not to use, if you need to give your business analyst direct access to the data, then you certainly can't do that or don't want to do that, with the exception of Couchbase, because Couchbase does have a SQL layer on it and it has a web interface. If you need complex transactions, you're out of luck. And if you actually need to do joins, you may not need to do joins if you can denormalize your data correctly. But if there are situations where you find a lot that you are storing in your document, in your MongoDB document or Couch document, an object ID that points to another object, and you're doing that a lot, then you might need the next database I'm going to talk about, which is graph databases. Graph databases were designed for just that. They're designed to solve the problems of modeling highly relational data. I gave a talk on graph databases last time I was up here, so you can reference that if you want to learn a little bit more. They are a node is basically a schemaless collection of properties. So if you have a person node, it's you can have sort of any properties that you want attached to it. Of course, the ID is necessary, but you can add the name, first name, last name, email address, whatever it is. So that's what a node is, and then you can have relationships to other nodes, and you can sort of arrange them arbitrarily. But the power that it gives you is it gives you sort of natural modeling for complex relationships. You can model all kinds of things, hierarchical data. So if you got a person who, you've got like a company structure, so there's a boss, and then, there's this person, they're the boss of these 3 people, and they're the boss of these 3 people, and they're the boss of these 3 people, and, you want to start from, a leaf. You want to start from a leaf and say, I want the adjacent, bosses, or so. You can, basically you crawl up the graph, you crawl down to the next one, and it's super easy. You can do many-to-many relationships. You can do multi-hop type of joins. It's really powerful. Neo4j's query language, Cypher, is absolutely the best thing ever. I wouldn't. I was gonna say I would give. No. All right. I can't decide what I would give to only query in Cypher for the rest of my life, but it'd be something pretty substantial. OrientDB is cool too. It is multi-model, so it can act as a graph database, and it can act as a document database. That's great. My issue with it is that it doesn't have as nice of a query language as Neo4j, obviously, and also with it being multi-model, sometimes the documentation or the API can be slightly confusing, because you're like, okay, am I using the graph am I using the graph API? Am I using the document API? It's kind of interesting, but it's great. It's great for you to be able to do both. When do you want to use a graph database? If you're building, for example, customer relationship management software or any sort of data management systems where there's lots of relationships involved, if you're doing data analytics, if you're modeling IT networks, IoT devices, social networks, of course, recommendations, that kind of thing. Graph databases are hard to scale or have the same scaling properties of SQL databases. Bless you. Have the same scaling properties of SQL databases in that you can't shard them easily, because how do you shard a relationship across multiple nodes? It's kind of odd. Also, it is on the consistency side over the availability side. So take that for what you may. When not to use them, so that's that, or if they're the wrong use case. But keep that in mind. The last one I'm going to talk in depth about, well, kind of in depth. I'm kind of breezing through all these, are column family databases. There's 2 flavors of these. There's Cassandra and HBase. And for those who are unfamiliar with column family databases, there's sort of 2 ways to reason about what they were. The first time I saw one, my eyes glazed over until I figured out there's 2 ways to reason about what they are. There's, you can either think about it as a key value store on a cocktail of Red Bull and steroids. Don't do it. It's not good for you. I haven't tried it personally. I don't know from experience. So if you think of a key value store, you've got keys and a value, right? A column family database. In a column family database, you'd have the key, which would be the real key. And then you have basically a collection of key value stores. So the key 1, value 1 would be column key, and then column value 1, column key 2, and column value 2, and so on and so forth. So it's basically a souped up key value store. But not just that, you can have super column families and super column families and super column families until you turn mad, if you want to. So you can have a key with a collection of key value stores, and inside of one of those key value stores is another collection of key value stores, and on and on. Another way of thinking of them is a SQL database, as a SQL database with all the parts that make it not scale taken out. Which that sort of understanding of it can lead you astray a little bit, because you could think you could do SQL stuff with them because they share some common terminology. They share, they both call column families tables. They say columns, then there's rows, but it's a completely different beast. But if you decide to lay with this beast and accept its demands, what do you get? You get scale, which is kind of a terrible pun on developers, but take it for what it is. It's highly performant, right? The biggest companies, the biggest web companies are using these, right? All your tweets go into Cassandra. Facebook is using it for all the messages that go through Facebook. Netflix is using it. Apple's got tons of Cassandra nodes. Reddit uses it. Basically, the biggest companies use it to store their data. It can run on a large amount of machines and store crazy amounts of data that would make any relational database, even the most expensive Oracle database, just die. It can do that. It can do that fairly easily. And if you have more data, you just add more nodes. Scaling is linear. It's also very performant. As a general rule, you can expect 5,000 operations per second per core. So if you've got a 4-core machine, that's 20,000 operations per second on commodity hardware. So it's fast. They're write optimized by virtue of using an LSM tree instead of a B tree, and I don't have time to get into the differences there. But they're write optimized. So you can do blazing fast writes. You can also do low latency reads so long as you're querying by key. I think Netflix did a test where they had 1 million writes per second, which is mind-blowing. Actually, it was 3 million writes per second because they had a replication factor of 3 going. So for every write, there was actually 3 writes that were going on. They're great, but there's a learning curve. You have to play by their rules. When do you? So there's 2 flavors. Again, on the high availability part, you've got Cassandra. On the high consistency part, you've got HBase. When you want to use them, when you're dealing with big data and you know your queries beforehand, they're especially good with writing activity streams, event streams, time series data, especially good with doing analytics. When do you not want to use them? If you want operational simplicity. You certainly don't want to use them because you're talking about configuring nodes and doing some certain and modeling your data the right way, modeling your data the column family database way. If you've got like a read heavy few writes website, like the movie database example that I talked about, where you just you have a movie database and lots of people come IMDb and lots of people come view it, but there's a few writes, then you're better off with something else. And then also if you require ad hoc queries in an online fashion, I don't mean to do an ad hoc query. You want to run a MapReduce job. You actually want to do an ad hoc query online, like right now. You probably want to look at something else. Some databases that I didn't get a chance to, some use cases and databases I'm not going to get a chance to take a look at. If you've got, for example, you've got a bunch of text documents or so, you want to put them in a data store and you want to be able to search them. Elasticsearch and Solr are great for that. They're distributed, of course, they can handle large amounts of data. You can do fuzzy sort of matching. You can do misspellings and still be okay. If you're building a real-time application, maybe something like, for example, a Google Docs where lots of people are collaborating on one document and updates are pushed to you, while someone else is editing it. You want to think RethinkDB. They model their database around that. Instead of having to poll for certain data, you just basically say, I'm interested in getting this data. So whenever the database gets updated or whenever this field gets updated, let me know. And it'll keep you updated, so in a real-time fashion. If you've got time series data, you want to look at InfluxDB, Cassandra, and of course, I don't do much of this. If you want to do offline archiving kind of thing, data warehouses like Teradata and Hadoop lots of things in the Hadoop ecosystem are built for this. So if you're talking about actual big data. So how do we sort of blend these two together? Well, first of all, this example is kind of ridiculous. Nobody wants to use six different databases in one sort of enterprise, but you might, you absolutely might. Actually, it's not that ridiculous. I lifted it from Martin Fowler, from a talk he gave. But yeah, you can store user sessions and probably your shopping cart in Redis because that's temporal data. You can do financial data and reporting in a relational database. Do analytics, user activity logs in Cassandra, and then MongoDB for your product catalog, and Neo4j is great for your recommendations. And if you're using microservices, or if you don't go full microservices and just sort of design your write your code correctly with proper abstractions and proper components, which everybody does all the time, right? Then it's pretty easy when you have an interface and you can just say, hey, session manager, give me this session, or save this session away, kind of thing. If you're looking at sort of like if you need sort of like a simple single source of truth type of situation where you want one database to have it all, then you can sort of replicate your data and say, okay, this kind of data is going to get replicated automatically to this other database, and then you can use this kind of data is going to get replicated to, say, Neo4j, and then you can use Neo4j for recommendations. You have various use of connectors. MongoDB's got connectors built in as of 3 dot something, and many other databases can let you do that. So in closing, here's a quote from Martin Fowler. If your project's not very vital and your team is not very good, use relational databases. That's kind of a slam. But I think what he meant, it was a response to a question. So because he was sitting at a panel, sitting with some NoSQL guys or whatever it is, and they asked him, so when should you use NoSQL versus SQL? I think what he meant is that if you don't care enough, like if it's not that important, if you don't care enough, and if it's not that important for you to go find and implement the right tool for the right job, kind of thing, then you can stay with the status quo and it's perfectly fine. But if you do, if it's highly important, all that stuff, then you don't actually want to go hunting for the right tool for the right job. And that's it for now. There's lots of ways to contact me there. At Timojo is on our child of Slack. Anybody have any questions? Yeah.
Let's say I wanted to use Cassandra, for example.
Yeah.
What practical options would you recommend as far versus running my own servers or looking to a hosted option?
Yeah.
What options are out there?
I would definitely say you probably want to look at a hosted option unless you have enough time to be a Cassandra expert. I know Rackspace, because we're looking at it right now. Rackspace does have a Cassandra team where they have a hosted Cassandra option. And I believe also there's a bunch of AWS AMIs for it as well. I don't believe there's anything in Azure quite yet, but I don't know. So.
Okay. And then I guess the other option would be Amazon's DynamoDB.
Yes.
And would you consider that comparable to Cassandra in your
Yes.
investigation?
So Cassandra borrows from Amazon's DynamoDB and Google's Bigtable. It uses DynamoDB for its sort of replication model with your leaderless ring type of replication, but in the end, it's a key value store. So it's not exactly a replacement for Cassandra because Dynamo uses that, and then on the at the node level, it uses Bigtable to be a column family database. So that's why it can be so fast with writes and good with reads and all that. So they're sort of two different beasts. Dynamo is more like a Riak, where it's a distributed key value store. Anyone else? All right, I guess we're good. So thank you very much. Yeah.